Hello, everyone. I am Bea de Ocampo, and our paper is entitled Industry 4.0 Framework Towards an Integrated Smart Traffic Management Solution. Here is the flow of my presentation. Manila is one of the most congested cities among 403 cities in 56 countries around the world, according to the 2020 TomTom Traffic Report. And this is before and during the COVID-19 pandemic, wherein mobility of road users are limited. Truly, traffic congestion is a very real problem of big metropolitan cities all over the world, and it is essentially viewed as a road capacity issue. However, the law of road congestion states that constructing new roads and public transport infrastructure would just invite more road users and thus would push the congestion level back to where it was. Other creative solutions, old and new, are continually being experimented on in order to discourage peak hour travel. On the technology side, aside from the smart traffic light solutions and navigation apps like Waze and Google Maps, continuous research also still abound, like self-driving vehicles, as well as finding other creative solutions to this mammoth problem. However, traffic congestion is not just a matter of infrastructure. In an Asian Development Bank report, traffic congestion is related to interactions on a roadway, which underscores the human element of driver behavior. Noteworthy are some local studies wherein there are other factors like a prevalence of the difficulty in understanding traffic signs and an apparent insufficiency of driver education, wherein a majority of the Metro Manila drivers learn driving only from acquaintances or even via self-study. So could the lack of discipline be brought about by the lack of education, or is it simply ingrained in the culture of the Filipino driver, as suggested in a newspaper article by Nolasco 2016? In an interagency report related to the United Nations Sustainable Development Goals 2030 initiative, the problem of a fragmented approach in resolving transport issues was cited, wherein there are different silos working on specific issues at a time. In this regard, UN advocates a multi-stakeholder engagement to ensure the political and social viability of those systems. Thus, the research question is, what framework could be designed to provide a micro and macro view of traffic management, which incorporates both technical and social elements towards an integrated solutions development? And therefore, the purpose of this grounded theories research is to develop such framework. This study will be significant to all local international bodies engaged in urban planning and any traffic-related matters, and especially city administrators, planners, and researchers in both the government and private sectors. This is for the purpose of policy making, formulation and evaluation of strategies, design and implementation of both technological and social innovations towards developing sustainable solutions. Industry 4.0, a socio-technical paradigm. Much has transpired from the time the term 4.0, Industry 4.0 was first used in 2011. But what makes Industry 4.0 different from Industry 3.0? Aside from the cutting-edge technologies of artificial intelligence, cloud computing, and Internet of Things, it is the humanization of processes, where human-machine interaction exists in a virtual environment. This is a core concept of cyber physical social systems, or CPSS, wherein there is the complex interaction between technological infrastructure, humans, and the environment, truly a socio-technical paradigm. Traffic culture. Traffic culture framework, as suggested by Osgan and Lajin in 2011, depicts the rich interplay of intricate factors, and on that basis, societal norms and values, as well as reinforced rules, together establish the boundaries for the behaviors of road users. The methodology employed the qualitative content analysis framework by Elo et al. 2014 towards the trustworthiness of analysis. Data collection, as there are many articles in Industry 4.0 starting from 2011 when the term was first used, the list of references was trimmed down as to areas of focus or themes. This was done by searching Google Scholar with the keywords Industry 4.0 or Industrial Revolution 4.0 together with bibliometrics. There were several well-cited bibliometric analysis journals. Sampling strategy. The journals with themes which are most related to traffic management were collected as base sources. There were also other fields with proposed frameworks that could provide insights in the ideation of managing and developing traffic solutions. Selecting the unit of analysis, categorization, and abstraction. Considering the various solutions to congestions that many countries are employing, common elements were identified and were categorized into groups of activities as a basis of analysis. These were then matched to various frameworks collected towards an adapted conceptual model for an Industry 4.0 based framework towards an integrated traffic management model. So using the bibliometric method on Scopus and Web of Science Index journal publications, the top themes were cyber physical systems or CPS, cloud computing, and Internet of Things, IoT, which are consistent with the current technologies related to smart traffic management. Researching further on frameworks with such themes, keeping in mind the techno-social factors resulted in cyber-physical social systems, or CPSS, wherein it is not just the interconnectivity of devices working together, but the importance of humans in the system and matching them with existing traffic demand management solutions. Through the lens of the UN SDG 2030 Transport Mobility Recommendations, the base framework chosen by the authors was taken from Johansson's 2007 six-level manufacturing control systems, which was cited by DiNardo et al. 2020. The basic processes are parallel to the operations and control of a traffic management system, and the aspect of an integrated planning approach can be incorporated. So briefly, at level 0, traditional traffic scenario, the basic elements of traffic management are situated: the traffic light, the traffic enforcers, and the traffic signs, whether static or electronic. At this level, each element and traffic systems are disparate. So traffic lights are standalone, there is no intelligence in the traffic light, so timing intervals are fixed. In unsignalized intersections, flow is manually directed by traffic enforcers based on their judgments alone as vehicles approach. Traffic signs are also planned and installed separately. At level 1, sensing and monitoring, there is already data gathering in traffic devices like cameras and speed control systems, which are usually installed in highways to detect basic traffic violations like breaking the speed limit. These are for monitoring and recording purposes only. At level 2, automation and control, there's already some intelligence in traffic devices where traffic conditions are considered as inputs. Here, traffic lights are already adaptive to traffic conditions. Inputs are coming from cameras and sensors. Contactless apprehension systems belong to this category, wherein traffic violations are captured on video and processed via machine learning, which results in violators receiving traffic tickets and evidences in the mail. At level 3, operations management, there's already the interplay between all the traffic elements from levels 0 to 2 and technology. It is here where digital networking and real-time man-machine interaction happens. The traffic lights are networked, and through IoT cameras and sensors, the algorithm adapts to traffic conditions, anticipates impending lane buildups, and also synchronizes with traffic lights within the same vicinity. So on the human side, traffic enforcers have access to real-time conditions of nearby intersections, thereby assisting them in making informed decisions in conducting traffic where they are. As for the more advanced technology of autonomous vehicles, it will also fall within this level where there may be minimal human interaction except for manual overrides for emergency situations. At level 4, integrated planning and coordination, stakeholders have a macro view of all traffic-related activities of various government and private agencies, particularly those involved in infrastructure development, management of city operations, policy making on the national and local levels, and research. This could even include the education sector for education on societal values. This also involves or could include collaboration with local and international agencies. So at level 4, there is no limit to the possible linkages within sectors, both local and international, towards solutions development with a multi-sectoral and multi-stakeholder approach. At level 5, sustainable traffic management All the other levels are brought together and managed by the main traffic management agency, depending on the solutions developed in level 4. Here is the overarching control of the general traffic governance towards enforcement, education, and engineering. In conclusion, the developed Industry 4.0 framework aims towards an integrated solutions development starting from the level of physical assets and moving up to the general governance activities, necessarily moving from the technical towards the social aspects of traffic management. It brings together infrastructure, technology, and the collaborative process of engaging multiple stakeholders in finding solutions, leveraging on real-time access of data as basis for formulating and implementing innovative management strategies. As for the recommendations for future study in the various literature reviewed, solutions were focused mainly on either infrastructure only or technology only with emphasis on road safety. In this regard, the authors recommend further studies on strategies towards changing driver mindset from just safety to an avoidance of traffic jams, towards contributing to making driving experience for everyone less stressful. That is how to instill the value of caring, such that one's actions do not cause delay and ire among fellow drivers. Further recommendations of the study would be the engagement in corporate social responsibility of society in general, to work with both the national and local government in the development and implementation of solutions, especially in the information dissemination of traffic policies, both old and new. This is in alignment with the World Bank definition of CSR, which is essentially saying that CSR is everyone's business. To end, let me mention some research towards assistive driving, and autonomous vehicles, wherein driving courtesy is being programmed into the algorithm of the vehicles. It is understandable to rely on the robust computational capabilities of machines, but should technology be a human proxy and thus exempt humans from exercising basic courtesy among fellow road users? Keeping society human in the midst of the swift developments in technology while keeping in step with societal progress is the focus of Industry 4.0 and the UN SDG 2030 target on transport sustainability. Therefore, infrastructure and technology must be utilized to make life better for humans rather than humans being slaves having to simply adapt to the advancements in the 21st century. And that concludes my presentation for today. Thank you very much.